So what we have here is a very basic potato cannon. It consists of two chambers, one chamber that we call the gas chamber, and one that we call the potato chamber. Finally, we have a sparker. So, how does it work? Well, first we just take a potato and we stuff it into the potato chamber such that no gas can escape. It can't get past the potato. The potato's taking up the entire tube. Then what we're going to do is we're going to open up the gas chamber, and we're going to spray, hairspray is what we used, or we could use any other kind of combustible gas. And we're just going to fill it up as much as we can, fill up the gas chamber as much as we can. And then finally what we're going to do is we're going to pull the trigger, and we're going to send an electrical current through the sparker, which will cause the electricity to arc between the two metallic points, and what should happen is it should cause the gas to begin combustion. And then as the gas expands, it will send the potato out the other end.
Okay.
Wow!
Exploded.
Where did it go? I think it's...
All right.
Get behind him.
All right. Go ahead.
Wow!
Ho ho!
Hey.
Now that we've learned about how potato cannons work, and we've seen them in action, let's learn just a little bit more about projectile motion. Now, as some of you may have already guessed, once the potato leaves the potato cannon, it actually acts as a projectile. This is because it has no acceleration in the x-axis, or its velocity is constant. However, its velocity in the y-axis is dictated by its acceleration due to gravity, or negative 9.8 meters per second squared. In order to solve for the initial velocity of the potato when it leaves the potato cannon, we would need to split that velocity into two separate components, an x component and a y component. In order to solve for the initial velocity in the y-axis, we need three things. The acceleration, which would be equivalent to the acceleration due to gravity, the change in velocity, which would be equivalent to the negative reciprocal of the initial velocity, because change in velocity would be equal to velocity after minus velocity before. And if we were to calculate for the change in velocity between the point in which the potato leaves the potato cannon to the point where it reaches its maximum height, the change in velocity would equal the initial velocity, as once it reaches its maximum height, it has a velocity of 0. And finally, we would need the change in time, which would be equal to half of the time that the projectile spent in the air. Once we have these three things, we need to rearrange the equation acceleration equals delta v over delta t and solve for initial velocity. In order to solve for the initial velocity in the x-axis, we would need to know three pieces of information. The change in distance, which in this example is 100 meters. The change in time, which would be the overall change in time between when the potato left the cannon and when it landed. And finally, we would need to know the acceleration in the x-axis, which, as you should remember, is 0 meters per second, as the potato experiences constant velocity while in projectile motion. To solve for velocity, we would use the equation delta d equals velocity times change in time plus 1/2 acceleration times change in time squared. However, since acceleration equals 0, we can cancel out almost that entire equation. All we would need to do afterwards is rearrange to solve for velocity. Once you have determined both the initial velocity and the x and y axis, all you must do to find the initial velocity overall is solve for the angle and the hypotenuse of the triangle you have created.